Hi, I'm Rajiv Shekhar. I'm a student of Vellore Institute of Technology. Welcome to my presentation on the usage of machine learning and deep learning in cybersecurity and cryptology. Before getting into our core area of discussion, I would like to brief about machine learning and deep learning. Machine learning is a subset of artificial intelligence that focuses on developing algorithms and models that enables computers to learn from data and make predictions, decisions, or classifications. And this must happen without being explicitly programmed for every single task. The combination of certain coding concepts and certain mathematical concepts and even some statistics and probability is machine learning. Deep learning is a subfield of machine learning that utilizes artificial neural networks with at least more than one layer. Artificial neural networks are computing systems which tries to mimic the human nervous system. This allows it to efficiently handle large volumes of complex data and achieve state-of-the-art performance in various complex tasks such as image recognition, natural language processing, speech recognition, generation of data like text and images, etc. So now let us get into some types of machine learning. Machine learning can be broadly classified into three types, namely the supervised, unsupervised, and reinforcement learning. Supervised learning involves training models with labeled data, where the model should learn to map the input to the output based on the provided examples in the dataset. This is useful for tasks like classification and regression. Unsupervised learning, on the other hand, works with unlabeled data. It lets the model to find patterns or structures on its own. It is commonly used for clustering. Clustering means it is grouping similar kind of data, and dissimilar data should be in different groups. And the another type of unsupervised learning which is commonly used is dimensionality reduction. As the name suggests, you try to reduce the dimensions or the number of features in the data set, and you can do it using unsupervised algorithms. The third type of machine learning is reinforcement learning. This operates differently, teaching an agent to make decisions by interacting with an environment and receiving feedbacks in the form of rewards or penalties. This approach is ideal for scenarios where sequential data making is required. Uh, I'll give you a few seconds to think where you may need sequential thinking. Yeah, probably you would have thought about driving, right? Yeah, a driving agent should be a reinforcement learning agent because it should learn from the environment's reward and punishments. And some of the other examples are game playing or robotics. We cannot say one type is better than the other. Each type of learning has distinct strengths and applications, and choosing the right one depends on the problem at hand and the nature of the available data. So supervised learning is again classified into two types. First, I'll explain how supervised learning works, and then I'll get into the types. So if you are sure what we are trying to predict or classify, then only we should go for supervised learning, which means that the dataset should have a target column or a column or something which you are trying to predict, like if the email is spam or not, or if the what to say, example, we are trying to predict the stock price, etc. Firstly, the labeled data is fed into the machine learning or a deep learning model, and it learns some patterns and conditions with the use of the data set. And the data set should contain the input features and also the labels for the corresponding features. And after training, when new data is fed into the model either predicts or classifies. As I said earlier, in supervised learning, there are two main types, classification and regression. Classification is like sorting things into different groups, such as deciding if an email is spam or not. So a spam email detection is a binary classification problem because there are only two classes possible. It's either spam or not spam. So for example, if you're trying to predict the customer's behavior, customer satisfaction, which can be either poor, good, very good, and excellent. So this is a multi-class classification because there are a lot of classes to classify. And regression is about predicting numbers. Like for example, guessing the price of a house or a stock price. We are predicting a continuous value, so it is called regression. For classification, we might use methods like decision trees, naive Bayes, support vector machines, or neural networks, which is deep learning. And while for regression, we might use simple algorithms like linear regression, lasso regression, or we can even use deep learning models, neural networks again. Which type we choose depends completely whether we are dealing with categories or numbers in our problem. Most of the implications of machine learning and deep learning we are going to see later in this presentation in cybersecurity and cryptology use either supervised classification algorithms or clustering algorithms to group similar data and find outliers, which is an unsupervised technique. So this is going to be a brief explanation about the machine learning process. The first step in machine learning process is data collection or gathering the relevant data. This can include various types of information such as numbers, text, images, audio, whatever is needed for the problem statement. Once collected, the data is cleaned and prepared for analysis. This involves removing erroneous and missing values, and handling the missing values instead of removing if it is needed, and formatting the data by using techniques like regularization, standardization, normalization, feature selection, dimensionality reduction, etc. And we bring it to a format which is suitable to input it to the machine learning algorithm. And the third step is model training. The prepared data is used to train the machine learning model, and during this stage, the model learns patterns and relationship within the data to make predictions or classifications or to just find patterns. The fourth step after model training is model evaluation or the usage of test data. After training, the model's performance is evaluated using a separate data set. Here, separate data set doesn't mean we have to have a completely different data set, but in most of the real-time cases, we just split the data set into half or 75-25% or something like that, 70-30, and we feed the maximum amount for training. And finally, we keep some of the data set to evaluate how the model performs. This helps determine how accurately the model can predict or classify new data and how we can generalize to all kinds of data in general. And the fifth step is model improvement. And based on the evaluation results, adjustments are made to improve the model's performance. This may involve fine-tuning hyperparameters or adding more data or increasing or decreasing the number of feature columns, and even trying different algorithms, which should be the last resort due to the cost and time complexity of training a new algorithm. And this process continues iteratively until the desired levels of performance is achieved. So now let us get into deep learning. So as you can see, this is the structure of a basic deep learning network. The individual units in a deep learning network are called neurons. And the most basic artificial neural network consists of three types of layers, namely the input layer, hidden layers, and the output layers. The input layer receives the input data, whether it's an image, text, or numerical values. And the input layer passes on this data after some calculation, which is not in the core area of our discussion, but the calculations are net input and activation. And after these both happens, it passes the data to the first hidden layer. The hidden layers process the input data through a series of mathematical operations, which I mentioned earlier, are net input and activation. And each neuron in a hidden layer takes input from the neurons in the previous layer and performs calculation and passes the result to the neurons in the next layer. If every neuron of a layer is connected to every neuron of the previous layer and also every neuron of the next layer, then it is known as a fully connected neural network. And the final hidden layer passes the output of it to the output layer, which produces the network's prediction or classification based on the input data. So now let us get into the implications of ML and DL in cybersecurity and cryptology. Machine learning and deep learning have become increasingly important tools in cybersecurity due to their ability to analyze vast amounts of data and detect patterns and also make predictions and even give precautions and prescriptions in some cases. Some of the applications of ML and DL are as given here, which are anomaly detection, malware detection, behavioral biometrics, fraud detection, and intrusion detection. Let us see one by one. So the first implication is anomaly detection. It is a technique of identifying rare observations which are determined statistically. These anomalous or suspicious events are further checked by experts and mitigated, because even though a machine learning model will be highly accurate, you cannot 100% rely only on them. So based on the machine learning model's prediction, we have to have an expert to mitigate it or correct it. This anomaly detection can be applied in various aspects. For example, to detect a failing server or a cyber attack. Denial of service is a type of attack which can be prevented using anomaly detection algorithms. So consider this graph here. Here you can see most of the points lying in a very less area, and you would have guessed what technique we might use here. As I mentioned earlier, grouping of similar points is known as clustering. So we cluster this area, and these represents the normal points, and everything far from this are called anomalies or attacks. So these points should be verified again if they are attacks or this simply normal outliers. And after verification, we can prevent it if needed. So the next implication is malware detection. Malware refers to a malicious software which is used to infect a computer or even a whole network sometimes. It exploits the target system vulnerabilities such as a bug in a legitimate software, which can be hijacked, which is very risky. And it has disastrous effects like data theft, extortion, or even crippling of the whole network. Most internet problems like spam emails, phishing attacks, denial of service attacks, which I explained earlier, have malware as an underlying cause. So the detection and prevention of malware is a crucial task these days. Now that we know what a malware is and how risky it can be to the security of an organization, let us see how to detect a malware. Detection of malware is usually a binary classification task, whether the file is malware or benign. Here, a benign file means that it is a non-malicious or a normal file. The first step is dataset preparation, which we do by reading one byte at a time from a file and storing the pixel value of that byte to create a grayscale image in final. And this must be accompanied with a label that if the file is malware or benign. Because malware detection is a supervised learning task, so it needs labels during the model training. The created inputs and labels are passed to a convolutional neural network, which is a deep learning model. And after training, we can input a new file's grayscale image, and the model will classify it as malware or benign. Here, we can if there is an advanced malware detection system, we can further classify a malware file into what type of malware and what type of attack it will cause. So the next implication which I'm going to talk about is behavioral biometrics. So unlike conventional biometrics, which we have been using for the past few years, like fingerprint or iris data or even thumbprints, behavioral biometrics identifies how people interact with application and devices. Due to the dynamic modality and the passive nature of behavioral biometrics, it is almost impossible to copy or steal. Today's behavioral biometrics technologies can capture more than 2,000 parameters from a mobile device. Yeah, it is mind-boggling. And these 2000 parameters include how the person holds the phone, scrolls through the phone, toggles between fields, the pressure they use when they type, and how they respond to different stimuli that are presented in online applications. So in simple words, they track how you use the phone, and it is completely different from anyone else in the world. So that's how they find if the correct person is using a phone or some unauthorized person is using the phone. And for by phone, I mean any device which should be protected. I'm just using the example of a phone. So the main problem of behavioral biometrics is that people work in very unpredictable ways. There is no magical or fixed set of behavioral parameters that are used consistently to tell people apart. That is the problem. And there is no generic model that everyone can be measured against, generating results that are accurate enough both on the false positive and the false negative side. Here you should understand what is a false positive and what is a false negative. A negative case, if it is falsely classified as positive by the model, then it's known as false positive, and the vice versa is false negative. And in behavioral biometrics, a false positive is crucial. False positive rate should be minimal, which is critical for preventing the identity theft or the fraud which is happening. And also the false negative side should be minimal. This is important for maintaining a optimal user experience, because you cannot accuse a you cannot accuse a normal user, right? He'll be frustrated knowing that he has done no wrong, but he's still accused. So that there must be very low false negative to maintain good user experience. This approach is known as individual feature selection, because for every individual device, there's no fixed set of features. So we have to find the optimal set of features for the individual user. This makes behavioral biometrics dramatically more malleable over other techniques. And the long-term effect is also very good, because there are no underlying assumptions in advance. So let us get into the fourth implication, which is fraud detection. The uncontrollable increase in the number of online users due to online shopping and e-retail and many other things like e-commerce, etc., has created a lot of opportunities for fraudsters. Yeah, it is very handy for us, but there is a lot of chance for the fraudsters too and attackers. It has led to a drastic increase in attacks such as identity theft, account takeover, and misusing credit cards, etc. Apart from enormous data volume and complexity in financial transactions, fraud detection has a few challenges to overcome. And one major such problem is handling of an imbalanced data set. So consider a credit card fraud detection model. Obviously, you might have thought that it is a binary classification problem. So it is using a supervised algorithm. We are trying to classify either if the transaction is fraud or it is a legitimate transaction. So here the data set will have 99% of the cases as non-fraud transaction. So this will create a bias in the model, resulting in very high false positive rate. Because here positive cases is the transaction is a fraud. So in most of the cases in the data set, the transaction is not a fraud. So it cannot find a pattern to detect how the transaction is fraud. So this will disrupt the customer user experience. Here the false positive rate is also known as customer insult rate, because we cannot falsely classify a good transaction as a fraud transaction. This will affect the customer's experience. And to solve this issue, we can use techniques like data sampling, like undersampling or oversampling. Getting into the final implication in this discussion, it is intrusion detection system. Intrusion detection is the task of building a detector, which is a predictive model capable of distinguishing or differentiating or classifying between bad connections and good connections. Here, by bad connections, I refer to the intrusions or the attacks happening in the system. The intrusion detection system monitors a network or the system for malicious activity and protects a computer network from unauthorized access from users. This may include even the insiders of an organization. The task is done based on some relevant features like duration of the communication, the protocol type used, either it's a TCP or IP, etc., TCP or UDP, etc., and the network service type, number of source and destination bytes, and even sometimes a set of flags. And the set of flags are used to check some things like if the packet is sent, the packet sent is a correct or a wrong one. Is the packet an urgent packet, or does the packet have any errors in it? These features are used to train a model which will classify the communication as a normal one or an intrusion or an attack. A robust intrusion detection system will further classify the connection if it is an attack, and it will classify into what type of attack we are facing. And the four most common type of attack which are classified are denial of service attack. Denial of service means that the packets are flooded to the server to create a bottleneck, so that the server cannot serve any other client which is requesting. And the second type of attack is unauthorized access from a remote machine, like guessing a password or something. Third type of attack is buffer overflow, which is an unauthorized access to super user privileges or root privileges from a non-super user. And the fourth and final type of attack is probing or surveillance attack, like scanning the port when you're unauthorized to. So coming to the end of our presentation, I'd like to summarize what we discussed in this presentation. So we started with what is machine learning and deep learning. What are the types of machine learning, namely the supervised, unsupervised, and reinforcement learning. And then we saw what are the types of supervised learning, which is classification and regression. And we saw a brief description of the machine learning process. And also, we also saw how a basic neural network looks like, how a basic deep learning network looks like. And then we saw 5 important implications of machine learning and deep learning in cybersecurity. Here, I would like to emphasize on one point that anomaly detection, malware detection, fraud detection, and intrusion detection, all four are binary classification problems. Sorry, let me correct myself. Malware detection, fraud detection, and intrusion detection are binary classification problems, or sometimes can be a multi-class classification. And anomaly detection, it is mainly done using a clustering technique. And behavioral biometrics, we can use any technique, or we can use combination of both clustering and supervised learning techniques. And it is advanced cutting edge technology which is going to grow in the further future. So this is the end of our presentation. Thank you.